They're one of the most iconic sights in the universe. Saturn's rings, glittering like a cosmic halo in the blackness of space. For centuries, they've inspired wonder, imagination, and scientific debate. But as breathtaking as they are, Saturn's rings are also one of the solar system's greatest illusions. At first glance, the rings appear solid, smooth, thin disks gracefully wrapped around the planet. But when spacecraft like Cassini got up close, a different reality emerged. These rings are not solid at all. Instead, they're made up of billions of individual particles, each on its own orbit around Saturn. These particles range in size from tiny dust grains to massive boulders the size of houses. They're composed mostly of water ice, with traces of rock and organic material. The purity of the ice is what gives the rings their brilliant, reflective quality. Saturn's rings reflect up to 80% of sunlight, making them the brightest in the solar system. But their structure is even more astonishing. Saturn's rings stretch over 280,000 kilometers across, nearly 3/4 of the distance from Earth to the Moon. But they're incredibly thin, with most of them only 10 to 30 meters thick. That's like stretching a sheet of paper across the width of a football field. Their near two-dimensional nature is one of the most extreme physical contrasts in the cosmos. The rings are divided into several main sections: the A ring, B ring, and C ring, along with fainter features like the D, E, F, and G rings. Each section contains thousands of smaller ringlets, thin bands of particles that often weave in and out, driven by gravitational interactions with Saturn's moons. The Cassini division, a dark gap between the A and B rings, is a particularly fascinating feature. It's not truly empty, but contains fewer and smaller particles. The gap is caused by orbital resonances with the moon Mimas, which pulls ring particles out of that region with precise, repeating gravitational nudges. Beyond the dazzling symmetry lies a more sobering truth. Saturn's rings are temporary. For much of history, scientists believed the rings formed with the planet over 4.5 billion years ago. But new evidence from the Cassini grand finale suggests otherwise. As Cassini dove between Saturn and its rings in a series of death-defying maneuvers, it gathered precise data on the mass of the ring system. The results were shocking. The rings are much lighter than expected, only about 1/1,000th of the mass of the Moon. This, combined with erosion and gravitational decay models, suggests the rings are young, possibly only 100 to 200 million years old. In cosmic terms, that's a blink of an eye. If dinosaurs had telescopes, they might have witnessed the formation of Saturn's rings. So how did they form? One leading theory proposes that Saturn once had an icy moon that ventured too close. As it crossed the Roche limit, the distance at which a planet's gravity can tear apart a celestial body, the moon shattered, its remains slowly spreading into a ring. Another idea involves the collision of comets or asteroids with existing moons, flinging debris into Saturn's orbit. Whatever the origin, the rings are now gradually fading away. Micrometeorites and radiation are slowly darkening and degrading the icy particles. Saturn's gravity is also pulling material back toward the planet in a phenomenon scientists call ring rain. It's estimated that the rings could vanish in 100 to 300 million years, meaning we're incredibly lucky to witness them now. But Saturn's rings are more than a visual spectacle. They're a dynamic system influenced by physics, resonance, and time. Waves ripple through them like sound through a vinyl record, caused by moonlets, gravitational pulls, and even Saturn's own seismic activity. Some ring sections show spiral density waves, similar to those in galaxies, offering scientists a unique laboratory to study gravitational dynamics. And the rings influence more than themselves. Their existence affects Saturn's atmosphere, its magnetic field, and even the orbits of its moons. The system is not isolated. It's a symphony where every instrument matters. At infinity beyond, we see Saturn's rings as a reminder of the universe's dual nature, eternal and ephemeral. They appear timeless, yet they are disappearing. They look solid, yet they are delicate and dispersed. They inspire wonder but also humility, reminding us that even the most majestic structures in space are transient. Imagine one day, far in the future, astronomers may look at Saturn and see only a bare planet, no rings, no glittering bands. The spectacle gone, only records and memories remaining. And yet, in this brief window of cosmic time, we are here. We are alive to witness Saturn's crown, and that is a privilege.